Hello, third graders. This is Mrs. Copeland, and I'm a math teacher in Charlotte Mecklenburg Schools. I'm going to be helping you with third grade memory joggers. Let's take a look at Week 10, Day 4, Problem A. Jose found the perimeter of a rectangle he drew. He said the perimeter of the rectangle was 20 centimeters. What could be the dimensions of Jose's rectangle? List all of the possible choices. Regina found the area of a rectangle she drew. She said the area of the rectangle is 20 square centimeters. What could be the dimensions of Regina's rectangle? List all possible choices. We have several things to remember. Perimeter is the length around the edge of a shape. We can find the perimeter of a shape by adding the side lengths. If we know the perimeter and a side length is missing, we can find the length of the missing side by subtracting the known side lengths from the perimeter. Area is the number of square units it takes to cover a shape. The squares form an array when finding the area of a rectangle. The length tells us how many squares long the shape is. The width tells us how many squares wide the shape is. We can multiply the length times the width to see how many squares it will take to cover the area of the rectangle. Jose found the perimeter of a rectangle he drew. His rectangle was 20 centimeters. So since perimeter is the space around the shape, if we were to start here, we would know that if we go here, 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 and here, that would be equal to 20. And we also know on a rectangle, the opposite sides are the same length. So that means if I were to go down the long side and down one short side, then I would be halfway around. So if I went halfway around, that would be 10. So when I'm thinking about the dimensions, the length and the width, I can know that halfway around is going to be 10 because 10 plus 10 is going to give us the total 20. So I have to think about ways that I could get to 10 to figure out the length and the width. I like to start with the shortest possible side. What if the shortest side was 1? Then I would go 1 and I would have to go 9 more to get to the 10. What if the shortest side was 2? I would have to go 2, and then the longer side would be 8. What if the shorter side was 3? I would have to go 3, and then 7. You may even be able to see a pattern already. What if the shorter side was 4? I could go 4, and then 6. And what if the shorter side was 5? 5, and then 5. It actually ends up being the same size. Since we have 5 and 5, we can know that we found all of the possible choices. Because if we went up one more, we would be at 6, and we already have 6 on here, and that would be 6 and 4. The second problem, Regina found the area of a rectangle she drew. She said the area was 20 square centimeters. This time we're not talking about perimeter, we're talking about area. And for area, we would have to multiply, as it told us down here, the length times the width to get 20 centimeters. So I can still begin to think from the smallest possible side. If one side was 1, so there was 1 row, how many squares would have to be in that row? There would have to be 20 in that row if there was only 1 row for it to equal 20 square centimeters. What if I made 2 rows of the 20 squares? 2 times 10. What if I made 3 rows? 3 times, I couldn't have even rows, so it wouldn't be a rectangle. So I can't use 3. 4, if I had 4 rows for 20, I would have 5 in each row. 4 times 5 is equal to 20. And now, if I were to do another one, I would be back at 5, and I already have 5 as a factor. So now I know I have all of the possible choices. Thank you, and if you have additional questions about this problem, please ask your classroom teacher.